All right, guys. So logarithms are a little different beast. In our current situation, it's really um, interesting on how we're going to explain these because there's a lot to logarithms because they were created. So logarithms were created for the inverse of an exponential. So log base 2 and 2 to the x are inverses of each other, which is what we've talked about repeatedly. So if we look at this here, and I did this last time, so we're going to work with logarithms today. So if I work with logarithms, I have an idea that my first point is going to be 1 and 0, and my second point is going to be 2 and 1 because of the base right here. So the base always goes in the beginning right there. And then I also know that I have what is called the asymptote, which means it cannot cross, and it's right at 0. Okay? So we have this dotted line right here, which I didn't do a very good job at. It's more of a dashed line. It goes right there at 0. So we have that piece there. Now, this graph goes just like this, and it kind of curves that way. And then we'll just make that dot bigger and that dot bigger. So we have this graph that kind of curves just like that. Okay, now we have a shift of h and k. So don't forget we're working with h and k still. So if I was to put this on a xy chart, my original point is 1 and my original y is 0. And I have 2 and 1. Those are my original points. But like I said previously, we have an h and we have a k. So our h tells us to go left -1, and our k tells us to go up 2. So the reason it's left is because it's always the opposite. So it's always the opposite. So h tells us to go left 1. So we're going to go left 1 and up 2. And on this one, we're going to go left 1 and up 2. And then our asymptote is at y equals 0. So that's where this is right here. This right here, which is better here. I just got to get better at drawing those lines. So we know that is at y equals 0. That's y equals 0. Okay. Now I got to go left or right. Sorry, that's x equals 0. Let me erase that. That's x equals 0. And I need to go left 1, -1. So now my x is at -1. So that's where my asymptote is. So let's redraw this over here. So we're going to take this. We're going to go. Let's get rid of that. All right, guys. Watch this. Maybe. Maybe not. There is a way to not make it 45. And I had it before. How big is it? Oh well. I tried, guys. I was going to draw a nice straight line. So my new graph looks like this. So we have our asymptote at 1. We have our new point at 0 and 2. So 0 and 2. And we have our other new point at 1 and 3, because 2 minus 1 here is 1. 1 plus 2 equals 3. So we're going to go 1 and 3. And our line kind of tails off this way and goes off like that. So we have, that's kind of what our line looks like there. Okay, so that's our new shifted line. Well, our x-intercept used to be 1 and 0. So what is our x-intercept? Well, that's where our inverse functions come in. So let's go ahead and tackle the algebra on this one. So we've got our algebra. And we have y equals, what did I say? Log 2 x plus 1 plus 2. Log base 2 of x plus 1 plus 2 equals, well, doesn't equal anything. Y equals that. So what do we always do to find our x-intercept? So remember, for the algebra part, we're always looking for x-intercepts. So when we do that, we're going to take our log base 2 of x plus 1 plus 2 equals 0. All right, guys. So now we're looking at this going, okay, how do I solve this? Well, get rid of the 2. So we're going to move the 2 to the other side. So we get log base 2 of x plus 1 equals negative 2. Okay, so then we're sitting here looking at, well, I don't know how to do this. You have a log base 2. How do you get rid of that? Remember, when we're dealing, when we got rid of this 2, we subtracted 2. We did the inverse operation. When we take the square root of something, we square it. So we're always looking for the inverse operation. And so this week, if you remember, go back up here, our inverse operation is 2 to the x power. So that is the inverse of log base 2. So if we go back down to what we were dealing with, how do I get rid of log base 2? I make it an exponent. I do its inverse. So I do the inverse to both sides. So that would create the fact that this log base 2 and 2 cancel and simplify out and become 1. And I'm left with x plus 1 equals 2 to the negative 2 power. And if I clean this up, I get x minus 1 equals 1/4, because this can be written as 1 over 2 to the second power because of the negative exponent, which is 1/4. That's where that 1/4 comes from. Oops, that's a plus 1. And we subtract 1 from both sides, gives us 1/4 minus 1. And x equals negative 3/4. So that's my x-intercept. I've just solved it. And it kind of makes sense because if we go back to the graph, here, look where it's at. That's at -3/4 and 0. And remember that this is at x equals 1, -1. So it's almost to x equals -1, which is about 3/4. So that pretty much makes sense. So this week, that's what we're dealing with. We're dealing with logs and exponentials, and that is how you solve your logarithm equation.